Alright, this is factoring trinomials in standard form. Trinomials are 3-term polynomials. Those are the most common. We have 4-term, 3-term, and 2-term. So we talked about 4-term, the factoring by grouping. And we have 3-term, which is, again, the most common. And then we've also got binomials, which we'll talk about in a later video. And these are trinomials that are in what are called standard form, when you have a coefficient with x squared plus a coefficient with x plus a constant. And that's typically how you see it, ax squared plus bx plus c. They use a, b, and c to represent the coefficients and constants. So this process has been adapted from your textbook. It's very similar to how your textbook teaches it, but I've added my own little kind of twist to it and some student suggestions to kind of help make it a little bit easier. So the first thing you want to do, I call this step 0, just to help it stand out on your mind. You want to check for and factor out any GCFs. You always, always, always check for GCFs. If you're stuck on a problem and it's not factoring correctly, it's most likely because you did not check for a GCF. So we want to get in the habit, before we do anything else, we check for and take out any GCFs that we see. Once we've done that, we're going to multiply a times c, so the first coefficient times the constant, and set up what I call a t-chart. So the textbook calls this the AC method, and they don't really use the chart. The t-chart is something I developed to help students organize their thoughts. And another student called this the CAB method, because it was easier for her to remember CAB instead of ACB. It doesn't really matter. What you're going to do is you're going to make a t-chart. You're going to have A times C on one side and B on the other. And a student said, oh, I'm just going to switch the C and the A, because multiplication, you can do that, so that it spells CAB. So she calls it a CAB chart, if that helps you remember. But AC, whatever, it doesn't matter. And then B is over here by itself. Then you're going to think, this part's the hardest part, you're going to think of two integers that multiply to AC and add to B. Now some students are kind of quick with this, and some students it takes a little bit longer. Your calculator can come in handy if you're not so good with your multiples, or if the numbers are kind of big. You can use your calculator to help you out. Once you have those two numbers, you'll write them in your chart, two numbers that multiply to AC and add to B. Then with those two numbers, those two integers, you're going to use those two integers as coefficients to split the middle term of the trinomial. So we're actually going to turn the trinomial into a 4-term, and your textbook does a nice job explaining that, and we'll go through several examples here. And then the final step is to do factoring by grouping, just like we just talked about in the previous video. So I have a ton of examples here. I'll work out some of them a little slower and then kind of pick up the speed. If at any time, of course, you can pause the video, jump ahead, try whatever ones you want, but I do have a lot of examples here, just so you can really get some good practice. This is one of the most valuable skills you can have in your algebra classes. So let's look at the first one. We have x squared minus 6x plus 8. The first thing I want to do is check for and factor out any GCFs. So I look at the coefficients, I don't see a GCF. I look at the variables, I do not see a GCF. You want to put a 1 in front of the x squared, that is your A, this is your B, and this is your C. And it helps to label them at first just so that you can get used to the procedure. From there, I recommend setting up your AC chart off to the side. So we're going to multiply A, which is 1, times C, which is 8. 1 times 8 is 8. And then B, which is negative 6. So you put AC on one side, B on the other. So that's multiply A times C, set up your t-chart. Now the next step is the hardest step. Think of two integers that multiply to AC and add to B. So we need numbers that multiply to 8, like 1 and 8 or 2 and 4, but they also need to add to negative 6. So 2 and 4 add to positive 6. If I want them to add to negative 6, I can make them both negative. If they're both negative, then they will still multiply to positive 8, and now they will add to negative 6. Like I said, some students are really quick with this, some students it really takes some getting used to. You need to know your multiples, 1 through 10, just very comfortably, 1 times 1 all the way through 10 times 10 and everything in between, so that you're very comfortable with your multiples. So with negative 2 and negative 4, and it doesn't matter which one's first, we're going to go back to our original trinomial. We're going to leave the first term the same. We're going to split the middle term into negative 2x and negative 4x, and we're going to leave the last term the same. So we've just taken a 3-term trinomial and turned it into a 4-term polynomial. So once it's into 4 terms, then we use our 4-term technique, which is factoring by grouping. So from here, we're going to look at the first 2 terms, take out what's common, and write the leftovers. Then we're going to look at the second 2 terms, take out what's common, and write the leftovers, which hopefully by now you're really, really good at. And then we'll reorganize these into back-to-back binomials. And if you've done this entire procedure correctly, when you FOIL these back together, you should get back to your original expression. So let's try that again. Here's another example. We're going to check for GCFs first. I don't see any GCFs. We have A, B, and C. You can label those if it helps. We're going to set up our chart. Some students can do this part in their head. The textbook encourages you to do this part in your head, but I like to make a little chart. Just, I'm a visual learner and it helps me see it. So you don't have to make the chart, but I do recommend it. Then you're going to do A times C, so 1 times negative 2 is negative 2. B is 1. So I need 2 numbers that multiply to negative 2 and add to positive 1. It would be positive 2 and negative 1. And always double check that they added correctly. Take your time on that step. Don't rush that step. That's the most important step. Then we will split the middle term with those 2 values. Doesn't matter which one you put first. And you use these as coefficients on whatever variable's in the middle. Usually it's an x, but it could be anything. Then we group. Here we're going to be careful with our negatives. We'll take out a negative 1, and then leave x plus 2 for factored form, x minus 1 times x plus 2. There are lots of other techniques for factoring. If you learned a different technique that works for you that you can remember, I'm open to whatever technique works for you. If you go to tutorials and they teach you a different technique, I'm open to that too. So you don't have to do it my way. Over the semesters, I found this is the most consistent way to teach students. It's not necessarily the fastest, but it is the most consistent. No matter what trinomial you have, this method will work. So we're just going to keep going along with some more examples here. Here's another one. We're going to check for GCFs. I don't see any GCFs. We're going to set up our AC chart, or our CAB chart, whatever you want to call it. A is 1, so 1 times negative 10 is negative 10. B is negative 3. I need 2 numbers that multiply to negative 10 and add to negative 3, which would be negative 5 and positive 2. I'm going to use those to split my middle term. Hopefully you've seen some form of this prior to this class. Oops, that should be minus 10. Then we're going to group. And factored form should be x plus 2 and x minus 5. And it's okay if this looks a little bit different because you wrote these in the other order, it's fine. As long as the 2 binomials you get are the same, it does not have to be in that order, as long as the binomials themselves are the same. Let's try it again, and again we're going to look for GCFs. I don't see any, then we'll have A, B, and C. A times C is negative 2, B this time is negative 1. So that would be negative 2 and positive 1. And again, I'm quick with this because I just have done this a lot. Take your time on that part. Make sure you understand why I'm picking those two numbers and not anything else. It's only one unique pair that makes it happen. You cannot just be any two numbers. You've got to make sure that you got the right two with the right signs to make sure they add to b. We'll have x squared minus 2x plus x minus 2. And we'll group x times x minus 2. Here there's nothing in common, so we take out a plus 1. And we still have x minus 2 for a factored form of x plus 1 times x minus 2. So it's just a procedure. You just have to learn the steps. Whatever technique works for you, you've got to get them factored. And when you FOIL them back together, it has to go back to the original equation. It's very important that you factor accurately every single time. You don't have to be the fastest. You just have to get it correct every time and not have any hiccups or hesitations. I'm going to pause there for just a minute. I want you to look at your AC pair, the pair we picked, and the two numbers that ended up in the final expression. So look at this pair and the numbers that ended up in the expression. This pair and the numbers that ended up in the expression. You'll notice that they're the same. So I picked -2 and -4. -2 and -4 ended up in the binomials. I picked +2 and -1. They ended up in the binomials. Same and same. That is only true when the leading coefficient is 1. So every single one of these had a leading coefficient of 1. A was 1. When your leading coefficient is 1, whatever numbers are in your pair are the numbers in your answer. And that's a very small little shortcut that only works if the leading coefficient is 1. I'm hesitant to show shortcuts because then students want to use them all the time, and they don't work all the time. For this shortcut from here to here, it only works if your leading coefficient is 1, and you have to be extremely careful. If you think you can remember that, that's fine. If you're afraid you'll overuse that shortcut, which is what really happens most of the time, don't worry about it. Just follow this procedure every single time. This entire process, you'll get faster over time, and you won't miss anything or shortcut anything. So this procedure works for any trinomial that you have. Alright, let's keep going. So the next one, I'm going to look for a GCF. I have 2, 4, and 48. Those are all even numbers, so that's one giveaway that there is a GCF. I'm going to take out a 2. It's going to leave me with x squared plus 2x minus 24. The 2 I took out is going to end up in our final answer, so I always bring it down. You don't want to leave it out or forget about it. It is part of the answer. But we're going to use the AC method with the leftovers. So my AC chart will have 1 times -24. B is 2. So I need two numbers that multiply to -24 but add to +2. And that would be +6 and -4. That's my pair. I'm going to leave that 2 alone. I'm going to split what's left using +6 and -4. And then I'm going to group. -4, that would become x plus 6. And then my final answer is going to have the 2 out front, and then x minus 4 and x plus 6. Just be careful with those GCFs. When you take them out, you have to leave them out front, and they are part of your final answer. My math lab will count it wrong if you do not put the 2. Alright, if you want to try the next one on your own, let's look at that one. We've got 3, 3, and 18. They can all divide by 3. That leaves me with x squared minus x minus 6. That 3 is going to come down and be part of the final answer. And then I'll set up my chart with the leftovers. So let's see, 1 times -6, and that's -1. Be -3 and +2. So I'm going to have x squared minus 3x plus 2x minus 6. And then I'll do some grouping here. X times x minus 3 plus 2 times x minus 3. So the final answer will have the 3 out front, and then x minus, oops, be more consistent there, sorry. You can put the x minus 3 first, but I usually put the GCFs first, and then the leftovers. So your final answer will have that 3 out front. Got a couple more on this page, and then I'm going to pause the video and I'll record a separate one for the second page. I don't want to have too much in one video. So that one's pretty messy. We've got x squared y squared minus 6xy squared plus 8y squared. So it looks kind of like a mess. Let's take out the GCF, which looks like it is y squared. If I take out y squared, I'm left with x squared minus 6x plus 8, which is much easier to look at. If you notice, that's actually the same as the first problem. So all I have to do is bring down the y squared, and we've already factored that one from before. So that's going to factor into x minus 4 and x minus 2. You're more than welcome to rework it, but the textbook chose to use the same one that you've already done, which just makes your life a little bit easier for this. So the moral or the lesson there is that sometimes they look awful, but once you take out the GCF, it's not that bad at all. And let's try another one. Here's another one that looks pretty bad. X to the 5th plus 4x to the 4th minus 5x to the 3rd. If you notice all those x's, we can take them out. If I take out x to the 3rd, I'm left with x squared plus 4x minus 5. Much easier to factor. So I'll bring down that x to the 3rd. I will set up my chart. AC will be negative 5, B is 4. So positive 5 and negative 1 will do the trick. I'll use those to split the middle term. I'll do my grouping. Take out a negative 1 for that second group. And I'll have x to the 3rd from the beginning times x minus 1 times x plus 5. So again, taking out GCFs can really help you out, especially if the problem looks impossible or too messy. Check for a GCF and see what you can do. I'm going to stop there. You have a whole nother page to practice. I will record a video working through these a little quicker, but hopefully you see the procedure and you have the process down.